Hi everyone, welcome to our February episode of GoingNative. My name's Gabriel Ha. I'm a program manager on the Visual C++ team.
And I'm Steve Carroll. I'm the dev manager for Visual C++.
So Steve, what do we have for our audience today?
So I think this is gonna be a great one. Today we're going to talk to you about build throughput. Our hypothesis is that build throughput is one of the major things that develops any particular developer's productivity on a day-to-day basis. If I can shave off a minute from your build time, I can move a mountain. We do a bunch of different types of episodes of Channel 9. We do ones where it's like, hey, look at all this new cool technology. This one should be hyper practical. I hope that you walk out of this with at least a few switches that you're going to want to go and throw to get better build performance and to make the world a better place.
And there's a lot of content in the episode as well. The way we structured it is when I watch an internet video, sometimes it's like I want the most practical stuff to be at the very beginning. So we tried to do that. The things at the beginning of the episode are things that you can immediately do. They're not complicated. They mostly just involve upgrading to newer versions. But for those of you who really want to squeeze out those seconds or those minutes, there's stuff at the later part of the video where you can take those things to heart as well. So hope you guys enjoy.
Hello, and I'd like to welcome you to our episode on build throughput for GoingNative. And today we have Sridhar Badugiri, who is a 20-year veteran of Microsoft. Sridhar, do you want to tell us a little bit about yourself?
I joined Microsoft 20 years ago, as Steve mentioned. I've been involved with C++ from the day I joined in some way. So it's been a nice, exciting journey. And every few years, build becomes an issue. And this time I took on the baton of getting our compilers faster.
One of our goals for Dev 12 updates and Dev 14 is to try to get significant improvements for build throughput, and Sridhar has been leading that effort for us. So the first thing we want to do is walk you through a little bit of the kind of data that we use to do our analysis and to kind of judge ourselves and how we're doing. So I think the first thing we want to do is take a look at the Dev 12 data.
We get data from both internal and external users of Visual Studio. And part of the data tells us about build, how long it takes to build. So if somebody starts a build, we know the begin and end events, and we can collect all of that. And we have a lot of data for RTM. And I'm going to just use update 3 data. We'll skip the rest of it. We don't have sufficient data from update 4, so we're not using that. I expect it to be it to be same as update 3, not much different. And what it shows us really is that other than for very tiny projects with 1 or 2 files, we see an improvement with update 3 in general in terms of how long it takes to build. For example, if we take all the builds that happen with RTM and update 3, and we create a graph which shows the percentile of builds, 95th percentile for RTM took about 125 seconds.
So 95% of all builds in the universe that we can see complete in under
125 seconds. And with update 3, when we plot the same data and analyze it, it's down to 85 seconds.
So we've seen, on average, for every build in the universe, we've seen a drop of about
40 seconds. I mean, 95% of your projects are experiencing significant wins.
Great. So I guess what we're saying here is our top recommendation is if you are on Dev 12 RTM, please, by all means, move to update 3. So what are the kinds of things that we did to help achieve those kinds of gains?
OK, so there were a couple of things. When I started looking at this, I wanted to make sure that there were items we could ship as fast as possible, so it was not all like wait for a couple of years before you get wins. And we found a few work items that were low risk and high value. So the first thing we did was we just improved the incremental link scenario. What we found was a lot of incremental links were failing because static libs were part of that project and they were changed, which meant something that could take maybe 10 seconds to link now took minutes. And so we fixed that one. And if you are using incremental link today, it'll automatically, you'll get that feature, that improvement. When you were linking, one of the things we saw there when we analyzed the time spent in link was a majority of the time was spent in PDB, creating the PDB. And so we made some improvements to the PDB code to speed it up. And all of these help with your incremental scenarios. We added one more switch to help speed up the linker. The new switch is called ZC inline. And what it essentially does is, previously we would, if a function was marked inline, we would still generate code for it, and the linker had to go and do a lot of work to throw away code that was not used. Now, if you throw this new switch, any function marked inline, unless it's referenced in that source file, we are not going to generate code for it.
Any gotchas with that switch?
One of the things is we have seen people throw this inline on a function, and they use it from a different source file, but not in the source file where they have that function definition, which means that you have a breaking change, a small break. And the way to fix it is remove the inline keyword, or put it in a file that's in a header file that's included by all the source files.
And actually doing it this way is more standards conformant anyways, correct?
Yes, it is standards conformance. We actually have blog posts about this, and so it actually goes in detail about what the break is, and it talks about all of that.
Move to update 3 and then throw /cc inline. Great. All right, moving on. We've actually spent a lot of energy in Visual Studio 2015 development also towards improving this build throughput stuff. Can you talk us through sort of like the principles that we use to drive that work?
Yeah, so when I started looking at build throughput, one of the interesting things we have heard a lot is from people who do full builds, typically in build labs. And they want faster builds. It's important and critical. But one of the other things that people don't notice, and I think Steve, as a dev manager, has a lot of stake in the ground here, is what happens when a developer builds. They make a small change, they build it, and let's say it takes 30 seconds, you already lost a little bit of context. If it takes 2 minutes, then you're
probably surfing Reddit at this point.
Yes. And so one of the things I wanted to focus on here was how can we make incremental builds fast so that the developer productivity is impacted positively. And typically in a day, developer can build 20 to 30 times. And if we save half a minute there, it adds up quickly across the team. And so we spent a lot of effort in investing in these incremental scenarios during WIS 2015.
So for Visual Studio 2015, what are the top wins that we're seeing for people that they'll get for free? What kinds of code did we improve?
So in addition to all the changes we have made in Visual Studio 2013 in the updates, one of the things we focused on was template processing. We have heard from both internal and external customers that when there's template-heavy code, we take a long time to compile. And fortunately, one of our internal partners, Bing, sent us a file that took them 600 seconds to compile that file.
Fortunately for us and unfortunately for them.
Yes. I mean, you can imagine if I make a small change to that file and I want to now test it, I can go get a coffee break. Heck, not a coffee break. I can have a breakfast and come back. So took that file, did a lot of analysis, and right now we can build that in less than 60 seconds. Yes, 60 seconds is still too long, but it's a huge file, and we have made significant wins.
So what kind of code is improved by that?
This is, a lot of it is template-heavy code. And yes, 600 seconds is extreme, but we also tried it with files that took like 30 seconds to compile. And now it's typically less than 10 seconds, more like 6-7 seconds to compile those same files.
And I know I'll get asked this question in the comments if we don't address it, which is that we did significant template reworking in the 2015 product, which is why we could not backport this to 2013.
I mean, as I said earlier, anything that was low risk, I tried to push into the updates for Visual Studio 2013, but this was not one of them.
But the Visual C++ Dev Manager hears your pain and understands that we need to do things in the updates if we can. Loud and clear, heard from customers. So that's the free stuff. You should see improvements in template-heavy code. If you want to go and improve further, what sorts of things should you be opting into?
Okay, so as I said earlier, we spent a lot of effort on incremental scenarios. So we handled incremental link, static libs, and Visual Studio 2013 updates. Now let's talk about two other scenarios. One is linking takes a lot of time. And as I said earlier, creating a PDB takes a bulk of the time, almost 50% in some cases. And how can we reduce that? And this is full link. And sometimes you do need to do a full link because you have changed too much. And we wanted to improve the life of developers even there. And so we added a new switch called debug:fastlink. Essentially, it tries to create a PDB from the linker that's essentially references all the other debug information, be it in other PDBs or in OBJ files. And so your link is extremely fast because the PDB processing is gone.
And I think, do we have that for default for some scenarios?
Yes, in certain configurations, if you create new projects, you get it by default for the configurations that would be most useful.
But if you're migrating your code?
Migrating the code, I think we're not figured out exactly what's a breaking scenario, so we will.
So we recommend that people who are experimenting with improving their build throughput should try to throw it there.
The other one is link time code gen. We have heard from a lot of customers who are using link time code gen. Either they have stopped using link time code gen because it takes too long to link, or they use it because the win that they get from using link time code gen is significant enough that they want to use it, but then take the productivity hit. So we came up with a feature that we are calling as fast LTCG, and essentially what it does is when you do the link time code gen the first time, it saves off information from the previous build, and now as a developer you've made a small change and now you're going and building it again. It reuses a lot of that information from the previous build, and then your link time is seconds as opposed to minutes.
If you've previously looked at LTCG and disabled it because of performance, this is a great time to reevaluate that. The quality of the code that it emits will be higher, and you can get it better trade-off in terms of build time.
And just this is a huge feature. I mean, it's a new feature, and it's one of the things that the team did was they started using it from day one on this component. So the backend team, which the c2.dll is the one that they work on, they ship, and as soon as the feature was in a usable state, they started using it.
Dog food eaten.
Yes. And now I think most of the tools that we build in VC also use that on a day-to-day basis.
So to sum up, for Visual Studio 2015, when you're migrating your programs over there, you want to throw debug fast link in your linker switches. If you are using debug slow link, you want to turn that one off. No, I lied. There's no such thing. And you want to go and look at fast LTCG, especially if you're using it. And if you're not using LTCG, you want to try it again with this. I think the next thing we want to talk about is our intern project. Do you want to set up the intern interview?
Yeah. So one of the things I had been looking at was PCH, precompiled headers. And its precompiled headers is used by a lot of different compilers to speed up your build.
It can make a big difference.
It makes a huge difference. And just as a high level, in common headers you include in one file, you compile it once, and the compiler saves off some data that it can reuse when it's building the other source file. So you don't need to go and re-evaluate all the header files for each source file that you're compiling. And so I had some Perl scripts, Python scripts, not very integrated together. It was like somebody wanted to do some analysis. It was like I had to do stuff. And then we got an intern working on our IDE team. And as we were evaluating different projects for him to work on, this was one of them. And then it was something that we thought would be a good project for the intern, as well as give our customers a good tool to analyze their PCH.
All right, and we filmed him before we left, so let's switch over to our intern. I'm Steve Carroll, the dev manager for Visual C++, and today we have an intern. This is Nikolai Semenenko. Can you introduce yourself?
Hi, I'm Nikolai. I am a fourth-year student at the University of Waterloo, and I've been here on the Visual C++ team for the past 4 months working on PCH.
Cool. All right, so today we're going to talk to you about a new tool that Nikolai developed as part of his internship that we're going to be releasing for all of you. One of the things we hear loud and clear from customers is that one of the things that we could do to make them more productive as developers is to speed up the amount of time they spend around waiting for a compile to happen. It turns out that one of the most useful tools for improving your build throughput is something we've had for a long time, which is the PCH file.
A PCH, or a precompiled header, is a special file that helps improve build throughput, as Steve said. It basically precompiles all of the contents of it once and is able to reuse that file throughout successful compilations in the project so that it doesn't have to recompile all of those things inside the PCH.
It's basically for things that don't change, you compile them once and the compilation will be reused over and over again as you make changes to the part of the code that you actually are changing.
With good PCH settings, you will be able to speed up your build by about 10 times.
Right, so this isn't like fiddling around on the margins. A great PCH file can make a huge difference in your day-to-day workflow. So talk to me a little bit about how you make those trade-offs. I want to get the 10x, not something smaller. So what sort of things do I need to do to select my PCH settings?
Some things that you would want to add to PCH for sure are system headers or stable third-party library headers, stuff like that. Stuff that you want to avoid putting into your PCH are things that change very often, because that means that you would have to recompile your entire precompiled header.
Because you have to basically start from scratch at that
Right,
point.
which
So
would take a long time.
Windows.h isn't going to change from day to day, except when you take a new SDK. Likewise, STL, we only change in certain major things.
Yeah, so you definitely want those things in your PCH.
Well, what about dependencies between files?
So yeah, if you have any tricky dependencies between files, you might want to avoid those as well. So if you have certain defines that conflict or that are used between certain header
Macro
files.
definitions that are
Yeah.
more like configuration macros that select one type of thing versus the other.
Correct. And so you want to avoid conflicting those inside your PCH as well.
Okay, great. So I think the easiest way to make this concrete for the folks at home is probably let's give them a demo of what it looks like.
Sure. So here's the project that I just opened up, and it does not utilize a PCH, and we're just going to see how quickly it builds. So as we see, that project took about 4.5 minutes to complete, and now I'm going to run the extension on this. There are several ways you can get to the extension, but I'm going to use one of them, and it's by right-clicking on a project and clicking Optimize Precompiled Headers. So this pulls up a settings dialog, and you can configure certain things here, but I'm just going to use the defaults, and I'm going to run it. Sometimes the preview takes a while to load. So here in this window, you can preview the changes that we are suggesting that you make to your project. So you have a project here, and then we have recommended and not recommended headers split up. You also have the PCH preview here. This PCH preview contains all of the recommendations that we make that you put into your PCH. And if a PCH already exists and it just wasn't being used, we just concatenate the recommendations to the bottom. So here you can preview the recommended headers, and you can see what the header contains, as well as drill down and see where it is being used in your project in which source files. So here you can explore the source file and also see which other headers we suggest that you put into your PCH from this particular source file. And once you click Apply, we make certain project configuration changes that will ensure that you use your precompiled header and write the changes to the PCH. So let's do that. So let's try building the project, and keep in mind that the changes made by the extension could potentially break it. So as we see, after running the extension, the project takes 32 seconds to compile, which is a pretty big improvement.
How did you make it do that? So what is the algorithm that it's applying?
There are certain rules that we run that you can configure in the extension. So you can go here and see what they are. So the way that we did this is we analyzed the data in the browse database, which is basically IntelliSense data. So here you can see certain rules that we run over it, and you can pick and choose which ones you want to run. For example, here we add headers to the precompiled header that appear in certain percentage of files. So currently we have 50%, but you can jack that up to 55 or 60 or however many you want. This rule counts how many source files a particular header appears in, and if it's with that percentage or greater, it'll add it to the PCH. The benefit of this is if a header appears in a large amount of source files, you probably want it in your PCH because you're using it a lot, so that you won't have to recompile it every single time. And once those rules run, we give you certain recommendations. And once you click Apply, we put all of the recommendations that you agree to and add them to the PCH, as well as make certain project configuration changes that ensure that the PCH is being used accordingly.
Great. So these new features in 2015, what kind of improvements are we seeing from them?
So as I said earlier, we are using real-world code and to measure our improvement. And one of the real-world code projects we are using regularly to build and measure our improvements is Chrome. It's open source, we can build it. And so we have used it for more than a year to test our compiler throughput. And with debug fast link, we essentially, the linking would take about 1,100 seconds or so when we started out. With debug fast link, it's about 800 seconds. So yes, it's still a lot of time, but you are saving 400 seconds of link time.
Great.
And this is across all the binaries, right? So if you're just building one binary in there because of incremental changes, then it will be faster.
Great. And what about fast LCCG?
Yeah, as I said, we are building C2 on a regular basis.
Which is our backend.
Which is our backend. And we are seeing about 3 to 4x speed up in link times because we don't need to link. I mean, people who know link time codegen know that we need to do a lot of processing there because we are caching information from the previous build. We're doing very little work.
So far we've talked about things in Visual Studio 2013, things that we did in 2015. Some of them are simple switches you need to throw. Some of them you just get for free. We're super duper serious about this project, so we also wanted to give you at least a little bit more advanced tips for if you wanted to go further and measure and report issues to us. So Sridhar, can you talk people through, like, if they're seeing issues, how they can help us to improve build throughput for them?
Yeah, I mean, yes, when you build a project, it's like, oh, it takes some time. You have no idea where time is spent. So I will walk you through all the different switches that we have. Turn on in the IDE to sort of figure out where we spend time. We'll see how long it takes for each project to build, which source file takes the longest, and things like that. So we can capture all of that information. We have switches. Some of them are documented, some of them are not, but I'll walk you through all of those. So now I want to show you some of the switch that can help you determine where time is spent in a build. I have a simple solution with 2 projects, default console application and the DLL. You can do this on any of the projects that you have. So first thing we want to see is which projects takes the most time to build. So to determine that, go to the tools options, and under the project and solutions you will find VC project settings. And if you look at this build timing setting, it's set to no, so it doesn't show any timing. Set this to on, hit OK. Now when you build, you're going to start seeing time spent in different targets used by MSBuild, as well as how long it took to build each of the projects. So let's do a clean rebuild. There you go. So I'll scroll up a little bit here. So if you look at this, it's showing you that it's about 1.2 seconds to build this project, and this is the list of targets that were invoked and how much time was spent in each one of those. So this is a good starting point to see which projects are taking the longest to build. So let's assume that for now console application is the one taking the longest. I'll go turn this off so that we can see what else happens. From a video point of view, I just don't want to clutter the screen with too much information. So let's say console application is taking long, and we want to dig deeper into seeing which files take the longest to compile or how long link takes to complete. So let's go to project properties. First thing we want to do is change the compiler settings. So under the C++, open it up, you will see the command line options. Under additional options, add the switch /BT+. It's not a documented switch, but it works in Visual Studio 2013 as well as Visual Studio 2015. Let's apply that. Let's also go add a switch to the linker settings. So linker, command line, additional options. Again, not a documented switch, but it's available in Visual Studio 2013 and Visual Studio 2015. So this is /time+. Let's apply this. Go here. Let me just clear this so that we don't have clutter, and let's just go build this one project. I'm just cleaning that project, and now let's build it. There you go. So what's happening here is, as a result of /BT+, you're seeing this line here. Let me hide this. we are trying to build stdafx.cpp, and c1xx.dll, which is the C++ front end, took this amount of time processing this file. And then c2.dll, which is our backend, which does the optimization and code gen. In this case, it's a debug configuration, so it's just doing code gen, not a lot of optimization. This is the time spent doing that. So you would see these 2 entries for each of these source files in your project, and then we get to linker. /time plus is dumping a lot of information here. So it has multiple passes. So it's saying in pass 1 it spent so much time, and pass 2 was so much time, and this is the total time for link. Inside pass 1 we do things with PDB, and it's writing a lot of stuff to PDB in parallel to doing the processing, and so it's saying what was the time it had to wait for PDB to close before it could go to pass 2. It was done with its own work, but it was doing something with PDB at that point. And then depending on other options you use with linker, like incremental link or link time code gen, you will see other output for things that we think are critical to linking, where we spend time there. So if you are using link time code gen, for example, you will see c2.dll here, because during linking we do the code generation, so we dump the information about c2. So these are some of the switches you can use to sort of narrow down where build is taking the most time, and then based on that send us reports.
Now that we've given people some information that can help them report any issues that they're seeing so we can continue to improve, are there any other last recommendations that you'd like to make for folks?
Yeah, one of the things that we have found is build systems make a huge impact. And we have been working with IncrediBuild very closely to make sure that all the changes that we have made works with their tool. And I believe they have some free versions that you can download for single machine use and try it out. And that may give you additional wins, especially if you're seeing idle cycles on your machine during builds and it's sort of serialized. IncrediBuild may help there. There are also other build systems that you can go and look at, but IncrediBuild is one that we know is very closely integrated with Visual Studio.
Okay, great. Thanks, Sridhar.
This was great talking to everyone. Thanks, Steve, for recording this. And if you have issues, feel free to capture the logs and send it to us, and then we can definitely figure out those extreme cases, take a look at the extreme cases and see how we can improve the build times.
That's our episode for today. Thank you so much for watching. And again, please try out all the things in the videos. If you haven't updated yet from VS 2013 RTM to the updates, you should definitely do that. And you'll find in the description below all the things in the video, from where you can find the links to VS 2013 updates, VS 2015, the PCH tool extension on VS Gallery, as well as a listing of the compiler switches, as well as some documentation for them. Please try those things out, and if you've gone through that and you are still seeing build regressions or any other issue, if you're not seeing the speedups that you're expecting to see, please let us know, and you'll find out how to do that in the description as well.